welcome everyone to this 14th Tech Talk. As always, just the same warnings that I always give, but just in case this meeting is being recorded, so just so that you're aware when you talk or when you share information or ask questions. And as always, we will upload the recording on YouTube so that people who cannot join today can still watch the Tech Talk afterwards. So we have the same agenda as usual. We will start with today's Tech Talk, around 30 minutes of presentation, and then we have some time for discussion. And then at the end, we will share some news and events related to Alaska. And of course, you can also share your news and events if you have anything interesting that you want to share with the rest of us. So I would already like to start with today's Tech Talk, which is the important and interesting part of today's session. Today we have with us Danilo Ardagna from the Politecnico di Milano, and he's going to present a talk with the title "A DevOps Approach for AI Applications at the Edge," related to his experience with the AI Sprint project. So a few words on Danilo. He works at the Department of Electronics, Information and Bioengineering at Politecnico di Milano, and well, he's quite a specialist in everything to do with the cloud and edge continuum, and with the frameworks and systems that must be developed and need to be developed to optimize how algorithms are placed on those continuums. Yeah, very interesting talk, very interesting experience, I think. So with this, I will stop sharing my screen and hand it over to you, Danilo, so that you can start with the real content.
Okay, thank you, Maria. So I'm sharing now. Do you see my screen?
Yes, we see.
In full presentation mode.
Yeah,
okay.
Full presentation.
Great, thank you. So welcome everyone. Thanks for being here today with us. As Maria introduced, I will provide a very high-level overview of the tools that we have developed within the AI Sprint project that I just finished. We had the final review last February. And so our project has two main ingredients. We have AI on one side, and we have computing continuum, edge computing on the other side. That these are the core technology we worked on. So if we look at the cloud market, the edge market, actually, we see that the edge market in Europe is in a good health, because these are the figures. We are about to reach 33 billion of edge computing only in Europe. These are European data. European companies already use edge computing solutions, and the edge is expected to double in the next 2 years. If we look at the market size, the 23% of the market is devoted to the cloud services that provides the backend to the computing continuum, and artificial intelligence weight is about 12% in the market today, and is expected to double in the next 2 years too. If we look at the reason why companies are moving to edge computing solution, these are reported on the left of the slide. And in particular, in AI Sprint, we had a focus on performance, on the cost efficiency of the solutions, and on cyber security aspects. So if we look at the reason why people are moving to edge computing continuum is a paradigm shift, actually, and is related to the fact that while cloud services has provided a backend for traditionally training AI solutions, AI models, if we want to use a cloud system, we have two main inconveniences. The first one is we need a computing, we need a continuous network access to the remote cloud. And on the other side, since we are accessing a remote data center, we pay for a latency that is introduced by the wider network. And that this is, this cannot really support application where, for example, you need milliseconds kind of constraint, 100 milliseconds kind of constraints. So the paradigm shift that we are living these days actually exploits the source of the data, the sensors. Nowadays, we have also solutions that at the IoT level, that where the computing capacity, the computing availability is growing, where we have an initial processing of the data. This process is not just reading a sensor temperature, but is already, we have computing capabilities there where we can run some simplified machine learning models, so we can learn a portion of the machine learning models. Then the next layer is provided by the edge, where we can exploit computing capacity, where we can, so that's where we can limit the latency of the computation. Well, actually, we devote the execution only to the remote cloud for the heavy part of the application that don't introduce real time or near to real time performance constraints. So that's why these are the layers that include in a simplified view the computing continuous solution, and these are the reason why people are developing this kind of solution today. If we focus on AI, and we have a focus on AI in our project, developing AI solution is usually more challenging than any other IoT applications. The reason why is because AI is hungry from the engineering perspective, and is hungry both from the cloud and the silicon perspective. So the silicon is the computing capacity that today is also on board on the devices. So for what concern the development of AI application, this is challenging because unfortunately there is still a lack of expertise, even if, for example, here at Politecnico, about 50% of students work on a master thesis on AI, but I mean, they are companies are trying to hire these expertise from young generation, and there are still not enough. If we look at the development tools, there are a plethora of frameworks. Usually, people would like to jump to the very last framework that is more innovative, is more efficient to develop the last machine learning model that raise the interest. The AI development is also trial and error. And for example, if you have an expertise for developing image recognition applications, these expertise cannot be transferred, for example, in developing natural language processing applications. Deep learning became popular because as we grow the training dataset size, we can increase the accuracy of the final model. But when we have to cope with these very large data volumes, privacy and security become really a concern. While if we move to the infrastructural part, at the cloud level and the IoT and the edge level, the issues are because we have heterogeneity of the application on one side, but also of the capacity and of the devices that are involved in the computation. And usually the elasticity and the efficient use of resources become very important, because on the edge side, we have a limited computing capacity, and usually these become a bottleneck. And moreover, we have sometimes also energy issues, energy limitation, because some devices run on batteries, for example. So if we sum up all these factors, these become rather important problem that need to be solved. If we look at then at the application per se, and if we look, for example, at production system like the one in Facebook, in production in Facebook, at Uber, at the big player, unfortunately, the machine learning model is just, we have a focus on these. All people today are really interested in the AI part, but the AI part is just 10%, 10-15% of the code of production system, because we really need to add more components on one side that helps the training or retraining of the models. We have some monitoring solution that try to cope and catch some drift on the model that would require the retraining of the machine learning models that are put in production. And also there are a lot of effort that need to be spent on the server infrastructure, because, for example, at Uber in pre-pandemic, we are run only for Uber Eats system we run like 2.5 million requests per second, which is really scary number of requests that they really need to be served in an elastic way. And if we look at the data, the result of the AI project, also there are a lot of failure. Gartner reported recently that 85% of machine learning projects failed. On one side, because they are usually challenging, we are really setting up very ambitious goals while developing new and novel AI applications. But on the other side, cost and quality are responsible of half of the failure. So these are mainly the emphasis that on which we put on our project. And as very final slide for motivations, at the beginning of our project, we are looking at which are the problems that small and medium enterprises in Europe needs to solve. And I take as an example Gregoire and Skylink that developed the farming for the toe use case in our project. So 3 years ago, about 3 years ago, when we started, Gregoire, I mean, they sell harvesters, they sell tractors. So they provide the machine on which the AI solution runs and the computer science, let's say, IT application runs. Skylink are the developer. At the beginning of the project, they had little expertise for developing AI solution. On the right, I'm just reporting the most popular framework, the most popular hardware devices that are provided at IoT at the edge layer, and the solution that are popular on the big player of the cloud provider. Definitely, there are really many technology. There are steepest learning curves, and we need expertise on many tools. These technologies are also running very quickly. There is a risk of cloud provider lock-in when we consider the solution if we want to cope with a more advanced solution that is the developer life. And moreover, they have also a need of customization. They have provided a solution for wine yards, while actually they would like, I mean, they have also customer on which they could sell their harvester for olives, for example. So they really have a need of customization and are really dependent on the cloud provider. They would like that the cloud provider would be the final choice of the customers, and they don't want to plug one cloud provider, specific cloud provider in their solution. So if we sum up all these factors, we realize that they really had a high risk of failure while developing an application. So what we developed in iSprint, we delivered a DevOps solution for developing AI application at the edge, and this will be the focus of the second part of my presentation. We provide performance guarantees in our solution, where, for example, we consider as performance metric not only the throughput or the latency of the application that are actually important, because we really have to serve application with a real-time or near real-time constraints, performance constraints, but we are considering also energy, for example. So we develop a solution that allow to move a long training job from one data center to another. For example, if in the second data center there are better energy condition, lower energy costs, or gainer energy availability. And we also developed a solution for the secure execution of the applications. These are the reference users of our framework. We try to help and ease the life of application developers, application managers, infrastructure provider, and SysOps, and also the end user. And if we look at the perspective of the individual user, if we look at the standard development way of the solution, for application developer, they usually need to design and develop ad hoc component of their application pipelines, and they usually need to manage manually the application parallelization if their performance really matter, their scenario. With our solution, we have simplified a lot the development process, and we provide a high level quality of service annotation at the Python level. And then everything is the performance, the monitoring, and the partitioning of a deep neural network is completely automated. And we can also leverage some annotation that support the parallelization of computing-intensive application or of the computing-intensive part of the application. If we look at the activities of the application manager, they usually have headaches because they have to manually configure the environment component per component, layer by layer of the edge continuum. And moreover, since this is a very time-consuming part, they don't usually optimize the performance. They have just a qualitative evaluation of the performance. What we did is to develop solution that automatically containerize the application. The deployment of this container then is completely automated and is TOSCA compliant. And moreover, we have a solution that fully automates the application performance profiling and optimization. And what we do is we automatically gather profiling data from the running component, and we develop some machine learning models that allow us to predict the performance on unseen configurations. Then we have also solution for the infrastructure provider, because usually at the infrastructure level, we have naive autoscaling solutions that are triggered by thresholds, CPU thresholds violations, for example. We don't have advanced solution for the scheduling of the long running training jobs. And really, we cannot guarantee on this way, neither the performance, neither optimize the energy consumption of the solution. What we did was to develop advanced solution for the resource allocation that can automatically cope with a workload variation while guaranteeing the execution time of the application. And moreover, we have also advanced scheduling solution that allow us to minimize operating costs if you are using a public cloud provider, or energy costs if we run the training of our application into on premises into private cloud, sorry. And finally, we can also solve the issue of end user in a standard clouds need to trust the cloud and storage provider, and in this setting, if they want to exploit some secure computing solution, they really need to manually create a confidential Docker images. They have to cope with encryption of the files. They have to cope with the distribution of certificates, of keys, and so on and so forth. In our setup, vice versa, we can exploit automatically trusted execution environment. We have also developed solution for the secure boot and measure boot of the nodes, and we have also solution that allow to evaluate quantitatively the privacy preservation of machine learning models. So, for example, we can guarantee that a machine learning model is resilient to some inference attack or some specific attack that thought with for AI specific tasks. These are the solutions we develop. Our application can run automatically on many cloud providers, and they are also compliant with OpenStack. So in this setup, what we develop, what we provide is the IP Studio that includes all the tools of the design time as a single Docker container that can be easily used. Then we have a SCOAN, which is a solution developed by our partner at the Technical University of Dresden, where we have this secure part. And then we rely on the infrastructure manager developed by our partner at the University Politecnico of Valencia, where we have this Tosca-based cloud orchestrator that simplify the deployment of the application component into an infrastructure. Then, I mean, some insight on the design pipeline. We start helping application developer and the application architect with this AI Sprint Tools suite, where we include a sprint design that support the quality annotation, PyComs, which is the solution developed for high performance computing by the Barcelona Supercomputing Center, and PopNAS, which is our network architecture solution, where we can obtain, just starting from labeled data sets, neural network that maximize the accuracy of the models and guarantee also the performance of the execution of the models at inference in production. to use our tools, what our developers and architects need to do is just to introduce these Python code annotations and to provide candidate resources in YAML format, the candidate resources that are target for the deployment. So I can say, I want to buy a drone with or without a GPU, or I can deploy my application on VMs that are based on medium or large instances. And all these alternatives will be profiled on one side. The best architecture will be obtained by the next tools. We have Toscarizer that support in the automated Dockerization of the application components. We have Scone that helps in securing the Docker containers. And to use Scone, we have some specific security code annotation. Then what additionally needs to be done is to provide the cloud keys for accessing infrastructure and the secure policies that are some detailed secure policies that are still provided just by YAML files without requiring, for example, the recompilation of binaries. Then we have the infrastructure manager that automated the application deployment. And at this stage, we're able to deploy an application that we can test and we can run in a minimum setup. Then what happened? We have Oscar Profiler that helps in the profiler of the application and in the training of the machine learning model. So we can say, okay, you can profile my component where I exploit from 2 up to 10 cores running, for example. And this can happen in, I don't know, in an NVIDIA Jetson or in a Raspberry Pi with some accelerator, and all is managed transparently. And whenever we have these machine learning models that allow us to predict the performance of our application on a sync configuration, we have Space for ID tools that runs an automatic design space exploration, where we can really identify the configuration of minimum cost that also provide performance guarantees. And finally, at this stage, we are able to automate the application into production with performance guarantees. To manage this optimization step, the application architect needs just to define which are the machine learning models that should be explored, and which are the optimization methods that we want to try to exploit to identify the optimal configuration. And again, this happens through simple YAML files without even writing some Python code for training the machine learning models. Then when we are in production, when we perform this deployment, transparently, we deploy also the AI Sprint runtime. The core of the AI Sprint runtime is the monitoring system that allow us to gather metrics from the application level down to the infrastructure. And we also build automatically some Grafana dashboard, standard Grafana dashboard that can be customized and collect, as I said, the information at the full stack from the application, but also from the infrastructure perspective in a centralized dashboard. We have all, we can see all happening from the IoT level up to the cloud level. The runtime, the runtime adaptation is managed by Krake, which has been developed by Cloud Indeed, and Space for AR, which is the design tool, Space for ID counterpart that optimize. So Cracker focus on energy optimization, Space for AR optimize the performance optimization. Then we have the runtime pipeline is managed by Oscar and Scar that provide a function as a service solution for the pipelines, the inference pipeline execution, which has been developed by Valencia. And finally, given our interest in AI, we have some vertical solution for that support the federated learning, the privacy assessment, and we have also an advanced scheduler that guarantee the training time and minimizing the public cloud cost or the energy cost in private clouds, as I mentioned. All tools are, most of the tools are really open source, are well documented. I invite you to take a look to our website, where we have actually, we have more than 100 pages user guide with a detailed tutorials and example code that you can access if you want to try to use our solutions. And now, I mean, the last part I will really devote, I have still, I think, about 7 minutes actually, And I would like to go through the use cases in a way that you have an insight of which are the application that validated our tools. So we developed a solution based for farming for the tool, where we'd like to modulate the chemicals that are sprayed on the grapes, actually. Then we have a maintenance and inspection solution where a drone is taking a picture of a wind farm to identify some defects on the structures. And finally, we have we have developed a personalized care application where we would like to assess the risk of stroke. These use cases have some peculiarities. For what concern the farming for the tool, they really had the need to processing application at the edge in a way that they can have a real-time control of the sprayers, and they have to fulfill some near real-time images on the field, because the cameras are put on the front of the tractor of the harvester, while actually the sprayer are on the back. So while the harvester is moving, we have a fixed time to process the images in a way that we quantify how much we can spray. For what concern the drone application, the maintenance inspection application, the time constraints are more critical, because the images, the first quality check step of the images are run on the drone, and these should be sub-seconds. And while if we move to the Barcelona Supercomputing Center healthcare use case, that's an healthcare use case. So there we really had the privacy and security concern because of the patient data. And moreover, we have also some resource constraints and scalability, because the input of this pipeline is an ECG that today can be taken with wearables. And if we have many users, then really we need to manage the dynamic scaling, because in principle, we can have bars of requests coming that need to be served, again, with some performance guarantees. These are the solution. For what concern the sprayer solution really run all on with a box that was developed and installed directly on the harvester, while on the cloud side, they developed a more advanced application where they have some disease detector and also some yield estimator, in a way that they can check with the videos that are automatically gathered by the cameras. These are processed in a way that can make a prediction also at the end of the yield, at the end of the season. This is really the solution. These are the cameras that we put on top, and that's the harvester. So you see that the cameras are here on the top, while the sprayer is the gray box that you see here on the right of the harvester. They achieve good results. They can implement these in fulfilling this time requirement, which is about 2 seconds, 2-3 seconds to modulate the sprayer. Then they have also developed some yield analysis, where you see they can get the estimate of the yield production, so they can really take a look to the individual videos, but they can have also automatically some average cluster mapping and some automatic reporting that are obtained in this way. And then they can map also the disease. They can really, from the images taken, they can recognize the disease, and they can plug this disease into some maps, and they can check how this disease is evolving also during the season. Then moving to the drone. Actually, they have a complex pipeline that starts with a quality assessment of the images that are taken. In the very beginning, they didn't have any automated solution, so the operator should check the quality of the picture taken by the drone. And then, I mean, this pipeline was run all in the cloud. What happened today, vice versa, is that the data capture, the quality assessment, and the blade part detection run directly on the drone. So these are the example of the picture taken. So the quality assessment, they really want to understand if the picture is in focus, if it's not blurred, so if the exposure is okay or not, and so on. Then they have a blade part detection that is really important, because given the blade part, you look for some specific defects, and then these specific defects run directly on the laptop of the drone pilot. And then here, if there is no damage, is a very good thing, because the processing can stop here, while vice versa, if there are some damages taken. So you see here, these are the parts that are, identified, and then these are the parts that then are sent to the final damage classification and severity assessment, that are some more demanding machine learning models that should run in the cloud, and actually run in the cloud, or eventually into the to the edge server that are available through a 5G data center, for example. The last one, so here you have some, the report that are obtained, and then that can be edited by the final post processing. Finally, the last use case is a use case related to the identification of the risk of stroke. Stroke is very important disease, because it's the second leading cause of death in Europe. It's the third cause of disability. It's growing, given also the aging population in Europe. We expect that it will grow by about 44% by the 2040. So it's a very relevant thing that we should take care today. This use case has been developed by considering some data sets that come from the ECG that can be taken with some variable, and here the focus is in detecting atrial fibrillation. And then there are also some extended data set that we can get from some questionnaires that the patient, some volunteers provided. And so in this way, we can have some advanced machine learning models that have been trained also by considering ECG running for about, we consider some wearable, some vests developed by Lubo, which is a small enterprise in Spain that provide these kind of devices. And so this device can take ECG continuously up to 2 weeks. And so we had about 9,000 hours for training data of these models. This model has been trained in the Barcelona supercomputing center on Mare Nostrum, and then these are deployed on the cloud. And so there is the edge part is a smartwatch that through a mobile app then connected to the cloud backend that identify the risk of stroke, and this risk of stroke that can be assessed by and checked by a doctor that is managing his own patient. So that's the last application. We develop also some MOOC that are available on several topics that we cover during our project development. And I think more or less I am at the end of my talk. I'm thankful to the partner that really work seriously on the project. We really provided very good results, we believe. And so this is like for thanking all the people that worked together on this project. And I'm open to questions, if any, from the audience.
Thank you very much.
On time. Yes.
Yeah, perfect.
Thank you,
Danilo.
Thank you.
On time, perfect.
You know, I really like to talk a lot. I'm Italian, so in Spain and a strict time limit, is difficult for Italians, right? So yeah.
I guess when you also have so much knowledge to share, then then we can accept that you want to talk about it.
You're too nice. Okay.
So are there any questions from the audience? If you have any questions, then you can just unmute yourself and ask them, or you can also paste them in the chat, and we will read them out loud. Then maybe just a question from my side, Danilo. I guess for this project you were working. Oh, sorry. Yes, Ryan, you can ask a question. Yes, just unmute yourself.
Yes, Ryan.
Hello there.
Hello.
Sorry, my internet connection is not very good, so I'm just going to unmute, not display the video. Thank you very much for the very interesting presentation, Danilo. Very excellent work. During your presentation, you mentioned about one of the key challenges in personalized healthcare was around privacy and security. I was wondering if you could expand a little on what kind of challenges specifically with respect to privacy and security are encountered in personalized healthcare, and in what specific ways the AI Sprint solution addresses these challenges.
Focus on, okay, I see. I didn't get, you with a focus on the healthcare or in general, the general solution we had on
more on the privacy and security. I'm more interested
privacy
in
and security part. Yeah, okay.
Yes.
So for what concerns the security part, we developed solution that automate, so Scone by our, let me go to maximize again this. For what concern the security part of the project, if we have an annotation for securing the functions that run in the pipeline. So for this, we can just say, I would like to have to run on a trusted execution environment, or I would like to have an encrypted disk, or I would like to encrypt my data, or I would like to have a secure network connection while communicating in my components. So we have just these annotations, and then these annotations are automatically managed by Scone that will identify this secure Docker container that then can be run on anything that support trusted execution environments, actually. So we are based on Intel SGX solutions, but recently Scone has been extended also to support some IAMD solution and also some RISC-V solutions. If trusted execution environment is not available, then we have some secure boot and measure boot solutions that support especially the training of the AI application, because usually the training happens in GPUs, and then GPUs we cannot encrypt nowadays. I mean, the data that is loaded in a GPU, and we cannot process automatically data that is encrypted. So in that case, we don't rely on trusted execution environment, but we have a secure boot, a measure boot, in a way that we can have the guarantee that whenever we start the processing, we have a certification that the operating system has not been touched, has not been corrupted, and also that our container has not been touched by one opponent. And moreover, we have also membership attest attacks. So after we have trained the model, we have solutions that allow us to verify that a specific data was not included in the training set, and which is also another relevant thing. So these are at a higher level. So the Scone solution are both at design time, because here you have some recompilation stages, while at runtime you have we are assessing continuously that there are no attacks to our application. And finally, at the application level, we have this training membership attack that we can protect. So these are for what concerns the security. Thanks for your question, Ryan.
Thank you very much. Thank you, Danilo.
Hope that I provided some more insights you were expecting. Okay.
Thanks. Any other questions from the audience? Okay, then I go on with my question. I was interested in knowing, for this project, when you started, I think there were like multiple technologies that were in different stages of development. And I guess it's interesting for me, your perspective as the coordinator of the project, how this integration worked, what kind of challenges you found, or if you have many, and maybe also like recommendations when one tries to integrate multiple open source projects in different stages.
Yeah. Okay, Matui, because for example, Krake and for example, Infrastructure Manager, Oscar and SCAR, we are in PyComps, by Barcelona Supercomputing Center, we're already, some of them were at TRL 8, let's say, so they were already used in production, while all the other tools I mentioned were developed from scratch in the project. So what we did was, on one side, we were considering some standards. So for example, the neural network, with it to be independent, we're based on ONNX standard, in a way that we can be even development framework agnostic. So if you are compliant with ONNX, and when ONNX is well received also the IoT level. So this was an important choice to focus on ONNX. And then the other part, the decoupling, was really to focus on the specific need that we have in the communication from one tool to another. And then we try to really simplify, to abstract. And so we have some reference YAML files where in these YAML files, we put all the knowledge that was shared among all the tools. And then, moreover, we had some custom parser and some additional YAML file that were specific for the tool. So, for example, sticking with the security part, we had these annotations that then were translated in some user information from Scone. But then in Scone, for example, if we have the need to the detail who are the user, which are the IPs that could connect to a reference node, then Scone provided his own YAML files where you have to add these specificities to use a specific tool. So the key insight was on one side to use standards wherever possible, to use Docker containers in a way that, again, we can abstract away, I mean, the details of the infrastructure. We can support the migration of components easily. And the other side was really to have this high-level analysis of the tools, to try to define some shared knowledge, and then but that to leave also the possibility to use all the facilities provided by the tools that in the 90% of cases maybe you don't need. You can stick with some default values, but then you have to provide the freedom to the end user to make custom to get the best of all of the tools. So that this was more or less the approach for integration. At the end, I mean, we were very critical. About 85% of the tools are integrated in the platform. So it's something that is really usable, and we would like the people still continue to use our solutions. Then I see that Ian raised a question.
Thank you very much. Yeah, Jan, go on whenever you want.
Jan, okay.
Yep.
We cannot hear you.
No, it's not working.
Okay, now?
Yes.
Yes.
Okay, hopefully it's loud enough. Yeah, ciao Danilo. Thank you for your very nice presentation. It was full of information. And I have a very specific question on the infrastructure provider and this ops part of your page or slide 12. Maybe you can switch backwards 2 slides.
Yes, I get the focus again.
Yeah, here. Okay, I was very interested in the part where you write down the optimized energy or cloud operational costs and energy aware runtime migration.
Okay.
Maybe can I rephrase my question? So I want to know how these operational costs can be reduced and how they are determined or how do you measure this?
So we have a different solution according to the fact that you are at the inference time or you are at training time. So at inference, what we do is we optimize mainly the cloud backend costs. Okay. So in the case we have we support the migration of components from edge to cloud according to the current load, and we support the scaling of the VMs on the cloud backend, and then the scaling is triggered by the machine learning models prediction. So we can really guarantee that if now I'm starting 5 VMs, it's because I really need the 5 VMs to fulfill my, I don't know, 200 millisecond time constraints, 500 millisecond time constraints. So that's what happened for the inference pipeline. While vice versa, for what concerns the training part, we have one solution that is based on Krake. And so we have some longer running jobs. The only assumption is that these long running jobs store some snapshots while they evolve. And that's something that you do use in these scenarios, because, you know, if a training is taking 2 weeks, and after 14 days, you lose your computation. You don't want to start from scratch. So that's a requirement. That's a minimum requirement for these long-running jobs. And then what we have a solution which is based on Kraken that monitors the energy available in different data centers, and really if there is a data center with a better energy profile, these long-running jobs are migrated, and we guarantee also that if you say, whenever you submit a job, I would like that the training happen in 2 weeks, we guarantee that the training ends in 2 weeks by exploiting machine learning models for the training time prediction on one side, and taking also into account the overhead of migration of the application from one side to another. Then for the training, then we have also developed a GPU scheduler, which on public cloud. So again, you have imagined that you have, I don't know, you can share a cluster of VMs in the cloud where you have, I don't know, you can decide to run up to a given number of GPUs. The GPUs can be also be heterogeneous. And then given the fact that the developer plug a deadline on the execution time or the training time of the application, what we do is we start the minimum number of VMs that are needed to fulfill these requirements, and whenever new jobs are submitted, maybe higher priority jobs, and we reschedule the solution, and we can start additional load, we can interrupt the execution of some running job if they can be postponed, and so on and so forth. So that's for the public cloud, but that's also for the, when you are on premises, we consider the energy costs, vice versa, we minimize energy costs. So in a way that really on one side, you make your developer happy because they will get the results of the training according to the due date that they set. And on the other side, we optimize the management of the cluster in a way that we can postpone jobs if it is possible, or we provide more resources to the more higher priority jobs, or to the jobs that are close to the due date, in a way that we can really fulfill that the training. If you say that I submit a job now, we get my answer tomorrow at 8 a.m., we do so, optimizing the infrastructure. Okay.
Okay, thank you.
You're welcome. Thanks for your question.
Maybe just a small note on that too. If any of you are interested, we also have a presentation. It's on your YouTube channel on Krake. I think it's Tech-Talk number 7. So
yes,
if anyone wants to look at that, then you can also take a look. And there's also another presentation on Scone. I don't
by
remember
Christoph
now.
Fetzer was
number 8. Yeah, so number 7 is Krake, and number 8 is Scone. So you can also take a look at that if you want to.
Yeah, and then the one will be scheduled, I think, in 1 month by Miguel Caballer from Università Politecnica di Valencia, and they will be on the infrastructure manager for the deployment.
Exactly.
One
yeah.
is coming.
Exactly. In May, yeah, at the end of May.
Yeah, in May. Yes, exactly.
Okay. One last question. We have time for one last question if there's anything. Doesn't seem to be the case.
So I stop sharing. Back to you, Maria. Thank you.
Thank you very much, Danilo. Thank you so much for the presentation. Then I will share again for this brief update on some news that we have. 1 second. Okay, so some news from Alaska. We were this week at the Cloud Fest in Germany, trying to make some new connections and trying to see what's new in the industry, if there are any interesting open source projects or tools out there that would be also interesting for our association. It's a really great event. You see here some of the roller coasters in the background, so lots of things to do besides networking. But of course, we also had the opportunity of meeting some of the Alaska members and some of the partners that we work with. So it was a very, very, very nice event. We hope that next year there will be more open source tools. So there was still some improvement there, I guess. Lots of proprietary tools still being used and so on. But yeah, there were also a few booths and so that had very interesting information. So yep, that's just an update from the ALASCA team. And then also a brief reminder that we are organizing a summit in October in Dresden. Our colleague Sarah presented in the last Tech Talk this event, and we still have the open contributions until the end of April, and we're still looking for sponsors. So if you want to participate, then take a look at our website. You will find all the information there, and we're really open to any kind of contribution that you might have. So we're open to presentations, workshops. So just if you have any crazy ideas, then just send them to us, and we will evaluate them. And then the next two Tech Talks that we have planned. The next one is going to be on the 26th of April. It's a talk on the Dresden Internet Exchange. So that's the next one coming up. And then, as Danilo was mentioning before, at the end of May, we have another Tech Talk related to one of the tools that is part of the AS Print toolkit, the Infrastructure Manager. So that's also a very interesting Tech Talk which you can plan. As always, if you're registered in our mailing list, then you will get all the information. We will send you invitations when the time comes. If you're not registered, then do so, and then you will get all the information. Is there anyone else who wants to share any other events or news, anything that would be interesting? No, doesn't seem to be the case. Then, as always, you can find the next Tech Talks on our website. You can subscribe to the mailing list I was mentioning before by sending an email to hello@alaska.cloud. We also have a form on the website, so any of those paths work. And if you missed any of the Tech Talks, or if you want to look at some of the tools that Danilo was talking about before, where we have Tech Talks on them already, then take a look at our YouTube channel, and you will find all of those there. You will also soon find Danilo's talk on YouTube. And otherwise, thank you very much for joining us. We will meet again here in a few weeks, 4 weeks, I guess, 4 or 5 weeks, at the end of April for next Tech Talk on the Dresden Internet Exchange with Matthias Wellisch from the University of Dresden and Danilo Ardagna from the Dresden Internet Exchange. And otherwise, I thank you very much, particularly Danilo, for the presentation. It was great to have you. And also to the audience for being here with us, and see you next month. Have a nice weekend. Bye.